Hey, Matt Matherson here with Math Madness. Thank you so much for joining us and being a part of the program today. You know how we feel about it. Thanks so much for joining us and being here. We really do appreciate it. Well, for today's episode, we're going to be talking about L'Hopital, that rule, when we're dealing with fractions that don't want to cooperate. We're trying to find limits, derivatives, and these things just want to run amok. So instead of me sitting here yammering on about it incessantly, I'm just going to demonstrate you why the L'Hopital rule is something very, very handy. Now, before I can get into that, I do need to show you a couple of conditions, although we're going to be just working with one condition today. And this is when we're allowed to use the L'Hopital rule. We have a plus or minus negative infinity or positive infinity over a negative or positive infinity. This is one of the L'Hopital rules that we are allowed to use when we have a fraction, rational function in this form. Plus minus infinity divided by plus minus infinity. Make sure we've got that. Okay. Well, here's the limit that we are going to be tasked with finding. We've got a limit as x approaches infinity, and our function here is 2x, and that's being divided by an e raised to the x. Well, we know over here, according to L'Hopital's rule, this first one, we've got infinity over infinity. Well, do we have an infinity over infinity in this particular instance? How do we find that out? Well, fortunately, we can just plug and go in this particular case, right? So let's just start with our numerator. We know we've got an x in the numerator, and we can see here that our x is approaching infinity. So what does that mean for our numerator? Well, it also means that the x in the numerator is approaching infinity, which means that 2x is approaching infinity, which means what? You got it, that the numerator in its entirety is approaching infinity. So let's just acknowledge that is the case here. All righty. Part of my infinity signs, sometimes they're good, sometimes they're not so good. All right. Anyway, let's go ahead and start dealing with the denominator. Well, again, we know we've got x is approaching infinity, and in our denominator, we have e being raised to the x. We know that this x is approaching infinity according to this limit here, yes? So we know that the denominator is what? Well, we know the whole darn denominator is approaching infinity as well. So I'm going to go ahead and acknowledge that as well here. Okay. Well, according to L'Hopital here, what do we have? Well, we do have a situation of infinity over infinity, and it says here infinity over infinity is okay for us to use L'Hopital rule. So I'm going to go ahead and acknowledge that we will be utilizing Monsieur L'Hopital rule. I've got it noted right here. Okay, well, let me go ahead and bring down our limit again, because we are going to be solving for this limit. It's the whole reason why we're doing this to begin with, isn't it? I think it is. Okay. Well, how do we solve for this particular mess? Well, fortunately for L'Hopital, he lets us take the derivative of this mess, creating a new mess that we can then take the limit of that new mess to solve for this mess. I promise I won't use mess anymore. Well, that was my last one. Okay, let's go ahead and take the derivative of this particular limit right here. Well, the derivative of 2x is simply just what? Well, that's just 2, isn't it? All righty. Well, we've got e to the x here. And what is the derivative of e to the x? Well, we've gone over this a couple of times, right? And it's just e to the x. Okay, not really big of a deal at this point, right? So let's look at this for just a second, and let's see what has changed since we've gone through this transformation here. Well, the x to the infinity hasn't changed, not going to change, right? But what's happened with the numerator? Well, we don't have an x anymore, do we? So we know that this 2 is just going to stay. Yeah, it's just going to stay at 2. It's just going to approach 2 forever and ever. All right. Well, what about the e to the x? What's going on with this particular case? Well, it's getting bigger and bigger, isn't it? Right. X is getting to infinity, meaning the whole darn denominator, again, is getting bigger and bigger, going to infinity. And so what happens usually, that's a pretty sad infinity sign. Let's try that again one more time here. Let me just do this and do that. Let's just pretend that's an infinity. I think that's the best it's going to get right now. So we've got a small number being divided by an infinitely larger number, right? Because this e to the x is going to infinity, 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 and beyond, right? So what happens usually whenever we've got a small number being divided by a much, much bigger number on the bottom? Yeah. We pretend that this whole darn thing is an atom, right? And we've just annihilated its atomic structure, and the whole thing goes to numero 0, as you can see. That's why we like the L'Hopital rule. Makes things like this very, very simple to take the limit of by utilizing those derivatives and the L'Hopital rule in its entirety. Okay, thank you so much for joining us. I am Matt Matherson. This has been Math Madness. We're going to see you real soon.